Okay, guys, you ready for another example? So, before we start, just a quick summary. Full theorem written out. Let f of x be a function that is continuous on a closed interval. It has to be continuous because we're talking about derivatives. If it's not continuous, it's not going to be differentiable. I can't take a derivative, so I can't talk about where it's positive and negative. So a function that is continuous on a closed interval, so continuous at the endpoints, and differentiable, meaning I can take the derivative on the open interval. So the derivative doesn't have to exist at the endpoints. That's not an issue. All right? So now what we say? We said if my first derivative is positive, my function's increasing on that interval. If it's an interval where my first derivative is negative, my function is decreasing there. And if my derivative is equal to 0 on an interval, all right, so it's 0. What does that mean? It's flat. It means my function is just a constant function. So we're going to look, I'm just going to slide you guys over. We're going to look at a new example here. So we've got the function negative x cubed plus 12x plus 5. And we're trying to answer the question, where does f of x increase and decrease? So what do we have to do? We have to take the derivative. We won't fake the derivative, we will take the derivative. So, the derivative, f prime of x equals negative 3x squared plus 12. Now what do I need to do? Well, I need to know where it's increasing and decreasing. So I need to know where it's positive and negative. So I need a number line, and I need to know where the zeros are. So I need to find the zeros of f prime of x and make a number line. Okay, what are the zeros of this? Take a minute and figure it out. Alrighty, so what'd you get? You had negative 3 times x squared minus 4. So I have negative 3 times x minus 2, x plus 2. So I'm going to make my number line. I'm going to put negative 2 from this one and 2. Now I pick a number in each region. So if I choose negative 5, for example, this is always negative. Negative minus a negative is negative. Negative 5 plus 2 is negative. Negative times a negative times a negative. All my derivative values are negative there. Let's take a number in between minus 2 and 2. Let's choose 0. We always want to choose easy numbers. Again, that's always negative. 0 minus 2 is negative. 0 plus 2 is positive. Negative times a negative is a positive, times a positive is a positive. So what does that tell me? It tells me that all my derivative values are positive here. Remember, this is a number line for the derivative. Okay, I'm plugging things into the derivative here. If I choose a number bigger than 2, say 10, that's always negative. 10 minus 2 is positive. 10 plus 2 is positive. Negative times a positive is a negative. So again, what do I know now? Well, I know that my first derivative is negative for less than negative 2 and greater than 2, so my function decreases there. And I know that it's positive in between negative 2 and 2, so my function increases. So I know now that f of x increases from negative 2 to 2, and f of x decreases from negative infinity to negative 2, and from 2 to infinity. And I'm done.